All right, today we're going to be working with the first derivative and the first derivative test. We're also going to be taking some second derivatives, but what we're looking for is the extreme points on the graph, meaning the minimums and the maximums, the critical points where the graph crosses the x-axis, where it changes from concavity of down to a concavity of up. So those are all the things that we're going to be working on today. So to start with, let's just remember how to find the first derivative and to draw the sign diagram. Those are going to be very important for us. So for the very first question, we've got our first derivative, our original function is this one right here. And so we're going to find the first derivative. And the first derivative of this one is going to be 6x squared minus 6x minus 12. Not so bad. So at this point, what we need to do is we need to draw a sign diagram with respect to the first derivative. So I would like to first off factor out a 6 because I don't like factoring something unless the leading coefficient is 1. That's just makes my life simple. So I'm going to factor out a 6 from each term, which gets me minus 2 here. And this one factors into x minus 2 and x plus 1. Now the reason I did that is because what I want to look for is I actually want to look for where this derivative equals 0. And so I can find that when I'm in factored form. So if I go ahead and have this set equal to 0, I'm going to see that x will equal 2 and negative 1. That's going to help me draw the sign diagram for the first derivative, because my sign diagram will start with putting those points on the line. And what I need to do now is find out what the value is. What I'm most interested in is whether it's positive or negative when it's in this area below negative 1, positive or negative between the two, or positive and negative above 2. All right, so if I'm looking for something simple, I can substitute in negative 2. Okay, I have 6 times negative 2 minus 2. That'll be a negative, so I have a positive times a negative. And if I have negative 2 here, that's also a negative. So positive times a negative means the sign right here will be positive. If I'm looking for something easy to substitute right here, the 0 would be great. So here I have a positive. 0 minus 2 would be a negative. So a positive and a negative. And 0 plus 1 would be a positive. So that means I have a positive, a negative, and a positive, which would get me a negative result. And if I'm looking for an easy number here above 2, I think getting of 3. So 6 is positive, 3 minus 2, that's still positive, and 3 plus 1 is positive. So they're all positive. When I multiply them, I'll get a positive result. So there is your first derivative and your sign diagram. Now, the second one, not so easy, because we're looking at a quotient rule. Okay, so again, sometimes just finding the first derivative is going to be the difficult part. So to find the first derivative, I'm going to need to know what u is. U is going to be x squared minus 4, which gives me its derivative at 2x. And v is going to equal x squared minus 1, whose derivative is 2x. Now, when I go ahead and put it in the quotient rule, I'm looking at x squared minus 1 times 2x, and then I'm subtracting x squared minus 4 times 2x, and I'm putting that all over v squared, which is x squared minus 1 quantity squared. Okay, so I'm going to simplify that top. I'm going to distribute the 2x to both things, so that becomes 2x cubed minus 2x. I'm going to distribute the negative and the 2x to both things over here. So that becomes negative 2x times x squared is negative 2x cubed. And negative 2x times negative 4 is positive 8x. And that's still going to all be over. I'm not going to worry about expanding that denominator. It's better in the form it's in. Simplify the numerator one more time. The 2x squared and the 2x cubed and the minus 2x cubed go to 0, and we're left with negative 2x and positive 8x, which gets me 6x, and that's being divided by x squared minus 1 quantity squared. So there is my derivative Okay, and I'm going to set that derivative equal to 0. So truthfully, I'm just looking where 6x equals 0. Okay, so this is my first derivative here, and now I'm trying to do the sign diagram, and I find out that it's 0 at 0, so that means I only need 1 point on my sign diagram. So I just need to substitute in a -1 and a +1 and figure out what those signs are. So if I substitute in a -1, I have a negative on top, and I have a positive on bottom, which means then that I'll have a negative here. Okay, but I do need to consider the fact that I have a rational expression here. So I do actually have values that I'm going to have asymptotes. And the asymptotes are going to occur at 1 and -1. So I've got to take those into consideration as well. So I'm going to put those as open circles. So I'm showing that they're an asymptote because I'm not actually going to have values there. So both of these will be negative because it doesn't matter what negative number I put in. It'll be negative there. And if I put in a positive number, let's say positive 2, I got a positive in the numerator and a positive in the denominator, so these will both be positive. So there's my side diagram for that one. So the third one, let me go back and make sure I mark my answers here. This was my first derivative here. Okay. So for the third one, it's actually easier. I'm looking at my first derivative equaling 3x squared. Not bad at all, right? So there's my first derivative, which is what it asked for. Then a set of sign diagram. So I'm setting that equal to 0, 3x squared. Set equal to 0 means that x equals 0. So I set up my sign diagram at 0. And what happens when I put a negative number in? Well, the squared turns it positive, so this is a positive. And what happens when I put in a positive number in? Well, it just stays positive. So this is going to be important later on that there is no sign change here. So that is something that we want to recognize. So we have positive to negative, negative to positive. We have no sign change over this, but we do have a sign change over 0. And we have no sign change over this asymptote. So when we put open circles, we have asymptotes, and we have no sign change over this one. So next up, what we want to talk about is what some of this stuff is going to mean for us. So if the first derivative does not change sign at a critical number is going to be when the first derivative equals 0, okay? We'll say when the x value when the first derivative equals 0. So if there's no sign change there, it is neither a minimum or a maximum. It's neither a minimum or a maximum. It might look like this, but you'll see that this is still a positively sloped curve. This is a positively sloped curve, so it didn't change signs. Here we have a positively sloped curve to a negatively sloped curve. Negatively sloped curve to a positively sloped curve. So that's why we will see a maximum, is because we went from a positive to a negative. When we go from a negative to a positive, we see a minimum. But when we go to a positive to a positive, we don't see a minimum or a maximum. Later on, we're going to learn how to tell if that's an inflection point, a point of inflection, which is a change in concavity. But right now, we can say it might be. We can't say for definite that it is. Okay?